Hey everybody, today I want to talk to you about how we maximise area in maths, and what we're looking at here is a question where we've got a farmer with a field. There's a hedge here on one side of the field and he has three sides of the field in the shape of a rectangle. We're told in the question that the perimeter must equal 60 metres, so that gives us a good starting point. If we look at the perimeter of the field would be this length plus this plus this. The hedge obviously doesn't count as part of the perimeter. So in order to get an expression for the perimeter, we would add y plus x plus y, which is 2y plus x, which we are told is 60 metres. So there's our first important piece of information that we get from the question. Now, we're asked to find the values of x and y that give a maximum area. Now, in order to get the area of the field in the diagram, we must multiply the length of the field by the width. So, in order to get an expression for the area, which I'm going to call A, I multiply x times y. Now, what I want to do is I want to find out what this is in terms of one of the letters only. At the moment, I've got the area in terms of two letters. So I'm going to use this information and I'm going to substitute it in here. So what do I get? I'm going to get that it's x times y. Now I can see from the expression above here that x is equal to 60 minus the 2y if I take that 2y across to the other side of the equal. So I'm going to get that the area is the same as y times 60 minus 2y. So just to recap, I've taken an expression for x from here and substituted it into the expression here. So it's going to be y times 60 minus 2y as an expression for the area, and that gives it to me in terms of y. So just to simplify, A is going to be 60y minus 2y squared. Now, in order to find anything as a maximum, you have to differentiate. So what I'm going to do is I'm going to differentiate A with respect to y. So what I'm going to get here is I'm going to get dA dy, and that expression simply means I differentiate A with respect to y. So I apply the rules of differentiation across this expression. So that's going to give me 60 minus 4y. Now, in order for it to be a maximum, I have to realize that the maximum occurs at the turning point, and therefore the turning point occurs when I differentiate and put the expression equal to 0. So, in order to solve this, I just take my minus 4y across to the right hand side. So that will give me 60 is equal to 4y, which gives me that y is 15. Now, in order to get what x is, I know from before that x is equal to 60 minus 2y. So what I'm going to do is I'm going to substitute in the value of 15 into this expression here to give me x. So x is going to be 60 minus 2 times 15, which is 30, which is going to leave me with x as 30. And if the question then asks me to work out the maximum possible area, I simply multiply these two numbers together. So the maximum possible area would be 15 multiplied by 30, which would be 450 square meters.